most of our everything is centered around machine learning and deep learning at this moment. A lot of algorithms like linear regression, logistic regression, decision trees. You have a data where there are height, weight, BMI, all these things. So hello everyone, this is Anirban. Okay, so I have experience of around 5 years in the field of artificial intelligence, data science, machine learning, whatever name you want to give it. All almost resembles the same thing, at least in the roles that whatever being offered in India. Okay, so I have experience of around 5 years, and I am a BTech pass out of 2018 batch. Okay. So yeah, with that is to introduce myself. Okay, and today I'll be conducting your AI Kickstarter, applied AI Kickstarter webinar. Okay, and so just to give you a little bit heads up about what I'm going to cover. So it is mostly the first thing, the few things that we are going to focus on today is, first of all, a little bit about AI and the types of AI that we want to focus today. Okay. There will be a little bit of technical understanding in terms of understanding, not coding, but technicalities which is involved in AI, like machine learning and convolution neural network, basically your deep learning as well. Okay, and at the end we will try to explore some tools where we can discuss about other things, like where AI is being used and what is the current state of the art technology and what is the trending thing that where AI is used. Okay, so just to give you, I think pretty much everybody knows over here, you know that artificial is anything which can be made by humans. Okay, and it is not natural, and we humans are natural, so our intelligence is natural, and artificial intelligence is something which we are developing at this moment, and we would also like to see it develop to a level where it will be able to become robots and also help our life easier. Okay, that is with respect to the AI. So there is a lot of understanding of AI. So what many people think, it is just like Terminator. You have seen Arnold Schwarzenegger's character. So we haven't reached to that level because probably if even if we are able to solve the software part of it, the intelligence part of it, there is a lot of robotics that yet to be solved. Okay, so in terms of intelligence, maybe we are just 15 years or 20 years away from that, maybe, and it could be fast enough. You never know. If there is a huge amount of data, if there is a research crack all of a sudden happens, then things could fasten all of a sudden as well. Okay, so in terms of the robotics, we lag behind. That is why you can't see currently things like what you saw in Terminator. Okay, now in terms of applied AI is just the use case that where AI is being applied. Okay, and how it is being applied. Okay, that is where the actual thing, that is what it will crack your or our job. Okay, in the field of this domain. Okay, so your biggest example is Alexa. Okay, when you ask it to play a nice song, okay, there is a mixture of speech to text. Okay, it's your speech is converted to text is converted to machine level codes. Okay, numbers and numbers to machine level codes which the machine understands, and then again does the reversing thing, and that is how it links to a song. So that is what one of the simple example of Alexa. Okay, AI is divided into three parts. Majorly, what in terms of we has a in terms of the jobs and careers that is there. One is the machine learning. One is the entire AI. Okay, that is, if you see this, you will understand the Venn diagram of AI. This is the entire AI field under which there is machine learning and deep learning that we are able to crack at this moment. Most of our everything is centered around machine learning and deep learning at this moment. So today our focus is on these types of AI. So these are the two types of, so machine learning, by machine learning and deep learning. So first you have to understand deep learning is also part of machine learning. But when I say machine learning as a separate, I talk about shallow machine learning or traditional machine learning approaches. Okay. So first of all, in machine learning, there are few steps involved. Like first of all, you get an input, there is an extraction, there is some sort of data extraction, feature extraction, that I would say. So suppose if you give a input of an image, there is a very base level types of features extracted. Okay, every image contains pixels, every pixels contains a digit, okay, which actually represent that pixel, like 255 and 0. 0 is for black, 255 for white. Okay, in between there are colors. Okay, so once you change these, your colors are originated from this. So these are values, are the features basically when we say. So we extract features from these images, then we design our model accordingly, okay, depending upon the model that you want to use. And then we get a output, whether you want to predict a car or not, dog or not, or you want to decide what a person is saying. Okay, same. Now in case of a input image, there could be a text as well. So so there are few limitations. Machine learning has a lot of algorithms. Okay, in terms of applied ML, if you talk about, there are a lot of algorithms like your lot of algorithms like linear regression, logistic regression, decision trees, and even other algorithms like random forest, XGBoost, gradient boost. These are the major algorithms that are being used in machine learning. Even knife based classifier and KNN. These are the things that are using machine learning. Machine learning. When I talk about machine learning, I told you it is shallow ML. Shallow ML is basically why shallow, because it doesn't work on a great amount of data. Okay, few lakhs of rows it can perform very well, but once it goes to crores and billions of rows, okay, rows of data, then your machine learning becomes slow. The accuracy doesn't improves a lot, and it fails after a point. Okay, so that is what ML is all about. Shallow ML is all about. And shallow ML is mostly, it is a statistical model, or you can say it is mostly predictive and statistical. There is no black box in it. What do I mean by black box? Like once you give a model, there is a interpretability. Like once you give a photo of a car, you can understand why a car is being, and there is a output also that is giving car. Okay, you can understand why is something being told as car and why it is not being told as car. Okay, that is what it changes in deep learning. Okay, like I told you there, like once I come to deep learning, I'll be explaining that as well. So limitations of machine learning are, it requires a lot of pre-processing. You have to create these features. You just cannot give an image and extract output and just give it to a model. You have to create features which can be feed into the model. So that is what feature extraction is all about. That is what is also known as data engineering in many roles of various startups and companies. Okay, and you have to build a certain type of structure so that the model can understand. So there is a lot of pre-processing that involves. Okay, machine learning model, just training the model is just 20 to 30%. Okay, but rest, 50% of the work involves in pre-processing of the data. Okay, and another 30% probably in deploying of the models. Okay, so uh, you know with the technology involvement, there is a lot of data that is being created. Okay, so there are a lot of possibility of using this data. So that is what I told you, deep learning comes to the rescue when the data size increases. If you look at the graph, the amount of data that is being increased on a daily basis is huge. Okay, last 2 years of data accounts to last 20, before that last 20 years of data. So whatever data has been produced in last 2 years, it is equal to the amount of data that's been produced in before that, before 20 years before that, like last 18 years of data if I take, okay, till 2020, and from 2020 to 22 it is equals to that. So the amount of data that is being produced on a daily basis is increasing exponentially. Okay, and with this much amount of data, machine learning fails, and that is where deep learning comes into play. Deep learning is something where it is like a rocket, where its fuel is data. It runs on data, it thrives on data. So that is what deep learning is all about. Okay, deep learning, it actually is more powerful. Okay, it works on, like, you can create various structure, various architecture around deep learnings. Okay, and it's easy to implement as well. There is not much of feature extraction that is to be done. Okay, you just give the image. Okay, and you can just create your architecture. Okay, obviously the image has to be denoised and blurring and all those things has to be removed. and then once you give the image, it is all after that, it is all by deep learning. Okay. So what are the types of deep learning? Okay, deep learning, there is plain deep learning, which is the deep multi-layer perceptrons. Okay, which is just a plain deep learning. There's nothing else. You just keep on improving the number of layers. There is hidden layer. Okay, inside a deep learning architecture, there are hidden layers. When once you keep on improving your architecture, that is how a deep learning grows. Okay, you take any sort of data. Okay, you just have a suppose tabular data. You have a data where there are height, weight, BMI, all these things, and you want to predict whether the person is overweight or something like that. Okay, beside the BMI part, and that is where a deep learning structure can help you. Okay, just a plain deep learning. When the data shifts towards convolution neural network, okay, or recurrent neural network, that is where your things changes towards convolution neural network. When things works on images, okay, when you have an image and you want to get prediction out of it, or you want to create something out of those image, you want to detect something on the image, object detection you want to do on the image, that is where your convolution neural network comes. And recurrent neural network is something when there is a text, when there is a sequence involved. When you talk, when I'm talking, every word is dependent upon the previous word that I'm telling. My next word will be dependent upon the previous word. So there is a link between each word I speak, right? I cannot say random words just place and then I'll be dyslexic, right? So in order to make this successful, there is something known as recurrent neural network architecture. And in order to work on images, okay, like cat, dog, like if you're self-driving cars, if you look at self-driving cars, best example. Okay, they use the dashboard camera to understand the front images, like where to drive and how to drive by looking at the traffic and everything. Okay, that is where your convolution neural network works into. And there is something known as reinforcement learning, which learns on rewards. Okay, so suppose you are given a job from travel from A to Z, and there are a lot of traffic lights, and you are being given that if you do not follow one of the traffic lights, you'll be penalized, and if you follow all of them, you'll be rewarded. So by every reward at every step you get, your model learns. So this is what reinforcement learning is. Okay, in India and in most of outside job also, reinforcement learning is a very research oriented side, which people are yet to crack on a lot of areas. Okay, there are a lot things have been cracked, like q learning is one of the approach. Okay, but there are a lot of research yet being going on. But CNN and RNN and deep learning, and deep plain multi-layer perceptron is the thing that people generally use in terms of deep learning. And why our focus is on deep learning? Because this is the current trend in the market. Okay, everything, all the research is on a deep learning. Machine learning that I have told you about just before this, Shalamal, there is no further research that goes on. Okay, there is tweaking of the algorithms that happens by changing the structure a bit, but there is not much research that happens, because those are ended, like those are closed things, like those cannot improve. Those are based on certain kind of formula and statistical formula. Okay, deep learning is something where there is a scope of research there, because deep learning is a black box. We also don't know, when you give an image to a model and you wanted to learn and predict something, you also don't know, like what in if it suppose if it is able to predict if something is cat, you might not know that why it is being able to predict something is cat. Suppose you predicting cat and a model predicting cat, both are not same, both could be way different. Okay, so a model predicting cat, it could be maybe because there was too much fur compared to a dog. Okay, that is the only thing the model saw. So maybe if you give another image which looks like a cat, it will always say it as a cat. Okay, because it hasn't seen something else. So that is why deep learning is a little black box. There is no interpretability power. You don't know if something has been predicted. You don't know why it has been predicted. It is like a broken clock can tell the time twice, right? So it is right, but sometimes it is, you are not expect you don't know what is the reason why it is right. It is right. That's the thing. So end goal doesn't proves the way it has taken in order to prove it is right. Okay, so that is what with respect to deep learning.